fractions quite often. So when you have a fraction within a fraction, you multiply the top and the bottom by the LCD of those inner fractions. So if you're looking at 7 over x and 7 over x plus h, the LCD is x times x plus h. So I don't know if you would have thought to do that. So that's what I did at the top and the bottom, because then the denominators cancel out. You end up with that at the bottom. So then when you multiply your negative 7 in, you actually end up with 7x minus 7x. So those ones cancel out again. You're left with negative 7h. And here in the denominator, usually we just have an h, but now the denominator is more complicated because we multiplied it by the LCD. But that's fine, we can still cancel out the h's. And what's then left at the bottom, if you make this h equal to 0, you're going to be left with an x squared at the bottom. Right? X times x. We have your negative 7 at the top. So that is why the derivative there is negative 7 over. And they often ask questions like this in the textbook exam where you actually have the denominator of x. It's either that or usually an x squared where you have to do some multiplying after. Okay, any questions on this one? All right, then you have to find the derivatives just using that rule that was in yesterday's note. So just to recap, that rule is saying that if you have a term, all right, however many terms, it has to be written in this form. Remember, that was the rule. F of x is ax to the power of n, all right? So you have a coefficient. That coefficient could be 1, all right? It doesn't have to be another number. You have a coefficient, you have a variable, it can be x, it can be a different variable as well, and then you have an exponent. Okay, so what you do then to find the derivative, if they don't say from first principles, if they say from first principles, you have to do this whole thing, this whole f of x plus h thing. If they just say find the derivative, you can this shorter rule. So what you do is you take the exponent to the front, you multiply it by the coefficient that's there, so you will get na. Then you have that same variable, but then you minus 1 from the exponent. And that is what is in yesterday's note that you have to copy down. And guys, in all honesty, if you didn't copy that down, that's on you. I'm not going to waste time going over it. I can see already there people with blank books. So I had a killer migraine yesterday, but I sat and I wrote out a note for you guys that you have work to do. And it's so disrespectful. Okay, but you couldn't do it at home. You couldn't just copy it down at home. So there we go again. Constantly other subjects are more important than maths. Okay, so now 3 times 3 is 9. And x, you have a 3 minus 1, which is a 2. And guys, I also don't understand why you have data to go on Instagram and WhatsApp and TikTok and everything, but when you have to access the PDF quickly, it's a problem that there's no Wi-Fi. Just making excuses. And the worst thing is I knew this was going to happen. Like I knew I was going to walk in here today and more than half of you wouldn't have done anything. And for this one, 2 times 7 is 14, and then x to the 2 minus 1 is 1. For this one, I did it in the example on yesterday's note, 4x to the 1. If there's no exponent, that exponent is 1. So when you take the exponent to the front, you have 1 times 4, which is 4. But then you're going to have, it's like this, x to the 1 minus 1. Yeah. Oh yeah, why did I put a 14 in? Yes, sorry. Was it just going to typo? A typo, a righto. Thank you. Is that what you guys also wanted to say? Oh, sorry, that is, yes. Oh, because I'm looking at that one. This one, yes, that is just 4 minus 4. Okay, what's your comment? Okay, wait, let me just quickly finish these. Lisa, what were you saying? Sorry, I misunderstood. Because here, this x becomes a 1 minus 1, right? Because the exponent of x there is 1. So when you minus 1 from it, it becomes x to the 0. Okay, so this is actually 4x to the 0, which is 4 times 1. Okay, sorry, yes. Hmm. So here for this one, are you talking about the derivative of 2? So remember, 2 is the same as 2x to the 0. So when you take that 0 to the front, it's 0 times 2, which makes it 0. So when you take that 0 to the front, you're going to say 0 times 2, x to the 0 minus 1. You want to write it out like that. No, so you, yeah. So that the derivative of the constant is always 0. You can also just remember that. And the reason for that is because a constant you can also always write as 2x to the 0. If you wanted to take a constant, which is just 2, and you wanted to write it in this form, so that you have a coefficient, a variable, and an exponent, the variable would have to be x to the 0, right? Because 2x to the 0 is just 2. Can we stop talking, please? So when you take that exponent to the front, then you're going to say 0 times 2, so the whole thing will become 0. So you can just memorize that, even that the derivative of that constant term is always going to be 0. So that's basically, if you're looking at this, you can see that the exponents are just going down by 1 every time, right? When it was an x cubed, the derivative is x squared. When it was x squared, the derivative has an x. When it was x to the 1, the derivative is x to the 0. And when there was no x, the derivative is just 0. Okay, we are going to practice more of this today, but we got it wrong, don't stress. Or if they ask if f of x was just a constant term, you would just say the derivative. If that was the only, if it was just 2. So guys, in this case for exam, this is all you need to show, just this line. Right? If you are applying the rule step by step, you can write that, but you don't have to. Yes. Usually, yeah. Usually they give a mark for each one. But you probably won't get something as straightforward as this. It will probably be something like this. Okay, that's what we're going to do. So you always have to put the exponent. So the thing is, in matric finals, they say in the main instructions, leave all answers with positive response. Yeah, so that's why we practice doing it here already, even if it doesn't fit. Yeah. So guys, please do that if you're getting negative exponents. Practice actually making those exponents positive. The thing here, when you're getting an x to the half, you don't have to write that in terms, but you can if you want. But usually they don't expect you to do that. So let's just go through G because G was a bit more difficult. Now, guys, you always have to put each term in that form, ax to the n. So in this case, it was 2x to the negative 2, right? So we need to now remember how to work with negative exponents. And this one, the square root of x is x to the half. Okay, you need to, this is stuff that we learned in previous grades that now is becoming a part of calculus, of finding derivatives. So we are going to do more complicated ones today, and then hopefully you'll get some practice in this. So now when you're finding the derivative of this, you're going to say 2 times negative 2. So you take that exponent to the front, that's negative 4. X to the, now I'm going to say negative 2 minus 1. That's where negative 3 is coming from. So it's always whatever your exponent was minus 1. For this one, you're going to bring the exponent to the front, a half x, and then a half minus 1 is negative 1. And then from there, you need to put all your negative exponents as positive. Then you need to move it to the bottom of the fraction. Okay, so the second term, there was already a 2 in the denominator. Okay, so that's why the x goes next to the 2. Some of you might have written it as which is essentially what it is, but you can't leave it like that. Okay, you have to put it all together. All right, on for C, can we stop talking? Yes. Yeah. All right, for C, you have to multiply out Thanks. Okay, for C, you have to, and I did write this on the worksheet if you actually look at it, because I didn't do an example like this in the notes. But guys, if you're getting something like this, you have to have separate terms, all written in that form, all with a coefficient, a variable, and an exponent. So here you actually have to multiply the whole thing out first. So I did write that on the worksheet for you, and C multiply out first, so that you have all of your separate terms. Okay, you can't have brackets and things that are being multiplied. You have to have a term, and a term, and a term, and a term, right, in order to use that rule. So that is quite important. So all of the kind of algebra stuff is coming into this section now. All right, multiplying out brackets. We're going to do some simplifying fractions today, doing like third form, negative exponents, all of that stuff is now coming into this section. Okay, so here you have to square this bracket out. Now you obviously could write the two brackets next to each other and pull it out. That's perfectly fine. You will get the same answer. And then once you've done that, you then need to take each term in this bracket and multiply it by x, and then each term in this bracket and multiply it by 1. And then you actually didn't end up with any like terms, which was unfortunate. But if you had like terms, you would have to obviously first add them or subtract them. Yeah. No, so you have to have separate terms, so you're not going to have to. Okay. So here we have, how many is this? 1, 2, you have 6 terms. Okay, 6 separate terms. So you're now going to find the derivative of each term separately using that rule. So what you do is you take the exponent to the front. There's a 1 there. Okay, so you're going to say 5 times 1, which is 5. X to the 5 minus 1, which is 4. Okay, the more you practice this, guys, the quicker you're going to get because it's just like, you know, a little rule that you must use. For this one, 8 times 3 is 24. So you take the exponent to the front, 24, x to the 3 minus 1 is 2. For this one, 16x, there's an exponent of 1 there, right? So you're going to say 1 times 16 is 16. Then you're going to do x to the 0. Okay, so that is why this is 16x, the exponent, oh, sorry, not the exponent, the derivative is just a number. X to the 4, you're going to say 4 times 1 is 4, x to the 4 minus 1 is 3, plus 8 times 2 is 16, x to the 2 minus 1 is 1, and the derivative of the constant term is always 0. You don't have to. This one. Yeah, it's from this one. Yeah, right. Did I skip that one? Yeah. 2 times 8 is 16, and then 2 minus 1. Okay, we are going to do a note on different notations because they are not always going to use the dash notation. There are quite a few different notations for derivatives. So just make a little heading. I know what I mean, right? They're not going to ask it in that way. It's just something that can do. It's not officially exported. So you have gradient. A gradient. The derivative is the same as the gradient of the term at the specific point. Okay. Yeah, or the gradient. No, there's every purpose. Okay, I tried to print this note before, but I'm just give it to you. Okay, different notations. Thank you. Let's listen. Okay, so if the function is given as f of x, which is what we've been doing now, then the derivative will be written as f dash x. That's like the basic notation. So if, for example, I'm just going to do a little example of each as well so that we get some more practice in finding the derivatives. If they say that f of x is 5x squared plus 3x, or something like. And guys, they can say in words, find the derivative, or they can say using the symbol, find f dash x, right? You obviously need to know both of those. So then f dash x, the derivative. We do have separate terms that are written in that form, a coefficient, a variable, and an exponent. So we're going to use that rule. 2 times 5 is 10. We take the exponent to the front, multiply it by whatever number is already there. And then you're going to have the same variable and you're going to minus 1 from the exponent. So if the exponent is 2, the exponent of the derivative is going to be 1. Okay, plus. The next one, 3, the exponent that we have of x here is 1. So we can say 1 times 3, right, which is just 3. But then we're going to minus 1 from the exponent of x. So if the exponent of x is 1, then the exponent of the derivative is going to be 0. Yeah. It's just the coefficient, yes. And guys, if we remember that the derivative is the gradient, right? If you just had a function y equals 3x, what kind of function is that? What kind of graph? A straight line, right? And let me actually just write it there on the side. If you were just looking at this one term, because we are finding the derivative of each term separately, so we can think of it in that way. If you have y equals 3x, this is a straight line. And what would the gradient of that straight line be? Y equals 3x. The gradient would be 3, right? The n value, the coefficient of x. So we get it from the rule, but we can also just think of each separate term as a function. Okay, so that is the notation that we've worked with so far. We may have different notations. So if the function is given in a different form, if they write y equals, so if the function is given as y, so we will do an example so we can see. Then they can do two things, the derivative. So you can use two notations. You can use y dash if you want. Or, and this is more common, the second notation that I'm going to write down, dy over dx. Now what dy over dx means is the derivative of y, all right? So the name of the function is y. Okay, so they're saying at the top, derivative of y, of the function y, function that has the name of y, And then the one at the bottom is saying in terms of x. So the variable that you have in your function is an x. It's dy over dx, derivative of y in terms of x. Just annotation. So it's always the one at the top is always the name of the function that you're working with, and the one at the bottom is the variable in that function. Okay. Yeah, maybe. When you write that on the formula, you say f of x plus a, so it's not f of x, but how do you write? So then you would just use like a g or whatever the other method. Because remember with function notation, they can use any method here. So you like the y. The function is going to start the formula is f of x. Okay, so 6x cubed plus 2x minus 1. So dy, guys, we see that the name of the function is y. Just like we had f of x in the previous example. The name of the function was f. Now the name of this function is y. So we put that at the top. And the variable in the function is x. So that one goes at the bottom. So we can use different methods as well. I'll do an example like that just now. So dy over dx, you can just remember that means that they are for the derivative. So now we're going to say 3 times 6 is 18 and x to the 2. It was 3 and the derivative is 22, 1 less. Plus the derivative of 2x is just 2. And the derivative of a constant term is just 0. If you don't have to write, you can just write it. Okay, what if they give you something like, I'm going to use different letters so that you can see now. If they say that is equal to 2t squared minus 3 over t, like that. So what is the name of the function? X, all right? S of t, yeah, if you want to write it like that. So the name of the function is s, so we're going to say ds. The name of the function always goes at the top. The ds over what variable did they use in the function? T. Okay, so we'll say ds over dt. Yeah, it just depends on how it's given in the question. So they can give it in this form. Yeah, or they can say find ds over dt. So you can always use this notation, guys. If it's up to you, you can always use this notation. Right? If they've given something in function notation, you can choose what notation you want to use. But often they ask a specific notation to know how to work. All right, so here I'm going to say 2 times 2, which is 4, and then t to the 1. Minus, oh, actually, let's just step out here. 3 over t, guys, is that in the right form? How do I need to write it? 3t to the negative 1. Okay, sorry, I forgot about that now. You would actually have to do that first. You have to get it in that form where it's a coefficient and a variable and an exponent. Now we can do that. So now I'm going to change this minus to a plus, right? Because it's negative 3 times negative 1. So that's going to be positive 3. T to the negative 2. Okay, that's a plus, guys, because there was already a minus in front. Let me put that minus there as well, right? So you would say negative 3 times negative 1. That's why that's positive 3. T to the negative 2. But now you're not allowed to leave it like that. Now you have to put that t squared at the bottom. The 3 over t. Okay. Okay. All right. if it is possible for you to make t the subject. Yeah. So they could do that kind of stuff. Yeah. Okay, that's the second notation, guys, the d over d thing. Then they can also ask it in this way. Yeah, so if they say the function is y equals this, find the derivative. That's not how we can do it. So you can, yes, so if they're given it in function notation, and the name and the variable in brackets next to it, then, yeah, then you would do the first. Okay, now number 3, they don't give you the function specifically. They give you this kind of thing. If the question is given as, you see what I mean by that now, sorry, that's confusing. If the question is given as dx and then in square brackets the function, now what this means, this dx and then the function, you're going to write what you need to find the derivative of in brackets. And this thing means derivative in terms of x. I'll show you now how to actually write the equation down, how to do it. It's a bit different from the other one. Then we'll just say dx and then in brackets the function. So if you have, for example, find or determine dx of the square root of x minus 3x to the 4. Right, that's how the question is given. So they're not giving you specifically the function and then saying now find the derivative. They're writing it like this. And you need to know that they often put the derivative of this function and the variable that they've used is x. Okay, so they can change that as well, guys. If they were working with a t here, they'll put a t next to the d. All right, if there's an x in here, then they'll put x there. Okay, so whatever this variable is, that's like a subscript, that is the variable in the function. Now, guys, here, because we have to first do some work, right? I can't derive this now. If it's written as the square root of x, what do I have to write that as first? X to the power of a half. So if you're still working on the function, you have to still write it in this form, which is a bit complicated. Some people forget that. I haven't found the derivative yet, but I'm not allowed to drop that dx. Only when I'm actually finding the derivative do I drop it. It's like that limit thing, right? Where we have to keep writing limit h tends to 0 until we actually make h equal to 0. Then we can drop it. Same thing here. We need to keep writing dx. So guys, if you have multiple steps where you're simplifying the function before deriving it, you have to write dx every time. Now when we're deriving it, now we can drop it. Okay, so now, what's the derivative of x to the half? Half x to the negative a half, right? So you take the half to the front, you multiply by the 1 that is already there. X to the half minus 1 is negative a half. See, now I'm actually finding the derivative. Now I'm dropping the d. Okay. So the next one, minus 12x cubed. That's my final answer. Can I leave the x to the negative a half like that? Make it positive. So I need to say 1 over 2x to the half minus 12x cubed. So I'm just going to write on the side here. Only drop the dx when you are deriving, finding the derivative. And guys, this is another place where you can lose notation marks. Okay, if you drop it too early or if you don't drop it, you can lose a mark for notation. Yes. Okay, then the last notation is almost like a mixture between 2 and 3. Yeah. If the question is given as, now for this one, sometimes they say d dx, and then they put the function next to it in brackets. So that's why I'm saying it's like a mixture. Instead of writing dx, the capital D with the subscript of x, sometimes they write d over dx of the function. Now this again is just saying derivative in terms of x. Just dx. Yeah, I mean this function is what we have to actually do. Yeah, I'm just going to do an example quickly. It's similar to what we've done before. So again, when we are simplifying the function, we need to keep writing d dx, d over dx. And as soon as we actually derive, we can drop that. So if, for example, they are saying this is a fraction that I'm writing in these brackets. These are just different ways in which we can also do the same thing. Basically. So what yesterday's note was about was using that rule, where you take the exponent to the front and minus 1 from the exponent. But sometimes they just ask it in a different way, so you just need to understand what they're asking. Oh, and the whole chapter. Yes, yeah. So we are applying the whole kind of gradient concept now, with the gradient is the derivative, but we are going to put all of it together to actually draw and graph. Okay, guys, so this one, we haven't done an example like this yet. Where you have multiple terms in the numerator and one term in the denominator. Guys, you still have to have separate terms. At the moment, I have one big term, right? One fraction. So I can't now, you're not allowed to like find the derivative of each term at the top and then the derivative of the term at the bottom. You need to have separate terms. Now, in grade 8, what did we do when we had multiple terms at the top over one term in the denominator? Can you remember? Yes, you split it up, okay, into 3 separate fractions. So now the notation thing is just like in the previous one. While we are still simplifying the function, we're not actually finding the derivative, right? We need to keep writing d over dx. But what we do to simplify this fraction, guys, the important thing when you're finding these derivatives, you need to keep saying to yourself, I need separate terms written in the correct form. Okay, so we're going to say 2x cubed over x minus 4x squared over x plus 1 over x. So you take each separate term in your numerator and put it over your denominator. Yes. Yes, I'm going to change, this one here, I'm going to change to an x to the negative 1. So guys, if your final term had an x in it, right, if this was like x, your last term was x, you could have factored, you could have taken out an x as a common factor, and then divided, then cancelled out the x at the bottom. Sometimes you're going to have to do that. Okay, I just didn't do that now, because my last term doesn't actually have an x in it. So I don't actually have a common factor of x in this case. Right, but if you did, then you could do like the grade 9 method, which is where you factorize the numerator so that you can cancel out the denominator. But guys, the bottom line is you need separate terms always. Okay, now we just need to simplify each of these terms quickly because I can. So here, again, because I'm not deriving yet, I need to still write b over dx. What's 2x cubed divided by x? 2x squared. Now that term is in the correct place. Okay, you also can't have it as a fraction with an x at the top and an x at the bottom. Our rule doesn't work for those types of terms. You have to have a coefficient variable exponent. Minus 4x squared over x is 4x. Plus, now 1 over x is x to the negative 1. You have to write it in that way. Now, finally, when we are applying that rule, when we are finding the derivative of each separate term, now we can drop the d over dx. So for this first term, I'm going to say 2 times 2 is 4. X to the 1, which we don't have to write. Minus, what's the derivative of 4x? Just 4. For the last one, I have a positive 1 at the front, negative 1 is my exponent. I'm going to say 1 times negative 1. So that's negative 1 x to the negative 2. Now my last thing that I need to do is I need to write that final term with a positive exponent. So 4x minus 4 minus 1 over x squared. So guys, just like in the previous notation, we keep writing d over dx with our brackets while we are simplifying the function. When we find the derivative, that is when we stop writing it. That's when we drop it. Okay, just see there. Okay, I'm going to give you some of these to practice on your own. So it's from your textbook exercise. Let me just read it. So guys, there are about 1 million questions in this exercise, so I just need to check which ones I wanted to do. And I just use someone's book. I wasn't in my class, and it's just not in my class. You have my test. Okay, guys, so it says here now, use the rules, not the definition of the derivative, but the definition of the derivative in that first principle. Okay, so you're not going to do that. Now we can use what we just practiced. I want you to do number B to G. And number 3. No, wait, I'm saying the wrong thing. 3, B to G, and 4. Sorry. I looked at the wrong numbers. 3, B to G, and 4. Sorry about that. All right, get going, please. There we go.